We're on section 3.1, perimeter, circumference, and area of triangles and rectangles. First definition, perimeter of a polygon. The perimeter of a polygon is the sum of the lengths of its sides. We can take an example of a square. Has side length S. What would the perimeter of the square be in terms of S? Yes.
4S.
Yes, it'd be 4S. All the sides are length S, so we'd add all the sides and we'd get 4S. It's the sum of the lengths of the sides. All right, let's do a parallelogram. One of the sides is A, the other side is B. What could we say the perimeter of a parallelogram is? Well, yes.
2A plus 2B.
Yeah, 2A plus 2B. Because the opposite sides are congruent. So yes, it would be 2A plus 2B. Circumference. Circumference is another name for the perimeter of a circle, or distance around a circle. So I could take, I might have a circle like this, and I have a circle like this, right? And any size, different size circles. I have these different size circles. If I measured the circumference of each one of these circles, right? And so I find the circumference, and then I measure the diameter. So if I take circumference of, this is circle 1, this is circle 2, this is circle 3. If I take the circumference and then I divide it by the diameter of that circle, I'm going to find that the circumference of all these circles divided by their diameter is always the same ratio. All right. What do you think we call that ratio? Anybody have an idea? The circumference divided by the diameter in a circle. Shatis?
Pi.
Right. It's gonna be pi. No matter what size the circle, the circumference divided by the diameter is always the same ratio. So pi is the ratio of the circumference to diameter of any circle, and that gives us a postulate that the circumference of a circle is the product of pi and the diameter of the circle. So it's pi d. And I got that because I knew that circumference divided by the diameter equals pi, right? If we solve for c, multiply both sides by d, we get c equals pi d. Now, the more common way that people know the the formula for circumference is circumference equals 2 pi r. You can use either one. Just if they give you the diameter of the circle, use pi d. If they give you the radius of the circle, use 2 pi r. 2r equals d, so we just replaced, in the equation on the left, we replaced d with 2r. So circumference equals 2 pi r. Questions? Find a perimeter of each figure. The figure on the top of the square is a semicircle. Alright, so let's do the figure on the left. Alright, you're always going to write the general formula. So how I grade these area problems, I give you a point for the general formula, then I give you a point for plugging in the correct numbers, then I give you a point for getting the correct answers. So there's 3 steps to it. So if we do this problem here, we have, if I did this circle, I do C equals pi d. What's my next step going to be? C equals what? Alright, we're just going to leave things in terms of pi unless it says to round. Yeah, it's going to be 10 pi. And I don't really have a calculation step because I plugged in the diameter, it's 10, so it's just 10 pi. Now, I could state this as, if I did C equals 2 pi r, my next step would be that equals 2 pi times 5. Then I do have to do a little calculation, so that would be 10 pi. I get the same answer. So it would be 10 pi, and this is, don't forget to give your units, it's inches squared. The double, after the 5, when you have a double apostrophe, that's inches. 1 apostrophe means foot. So we've got 10 pi inches squared for my circumference. No, it's not inches squared, sorry. Circumference is a distance, so it's just inches. So it'd be 10 pi inches, and in both cases, 10 pi inches for circumference. Let's do the perimeter of the other figure. So what could we use as a general formula for the perimeter of this shape? Perimeter is going to equal to what? Shatice?
Wait, the whole entire shape?
Yeah, I don't want the numeric answer, I want the formula you would use.
Or like the whole entire outline of
The
the shape?
whole entire outline, yes.
4s plus 2 pi r, or pi d divided by 2. And the pi d divided by 22 is what?
Okay, I agree with the pi d divided by 2, so we're going to take 1/2 the circumference, so it's 1/2 of pi d. Right? Do we want to use 4s? What do I want to use, Lily?
3s.
3s. Why?
Because the fourth side of the square is like inside the shape.
Yeah, it's not part of the perimeter, so it'd be plus 3s. And then we're going to plug in for s and d. What is the diameter? 1/2 pi times what? What would the diameter be? Elijah? Yeah, it's 7.4. It's the same as the length of the side. So it's 7.4. And then plus 3 times the side is 7.4. So we calculate that. We're going to get 3.7 pi plus 22.2, which is going to equal to, we'll round that one. Since it's got decimals in it, we'll go ahead and round it out. If I multiply that out, I'd get 33.82 We go to the nearest hundredth place, centimeters. That would be my answer. And I would circle it so I know that's the answer. All right, any questions? Okay. Yes, Shatis.
Will there be any cases if you have find a circumference and a perimeter of an oval?
No.
No?
We don't have a formula for that. Area. The area of a region enclosed by a simple closed curve. For every simple closed curve and unit square, a unit square is a 1 by 1 square. So for every closed curve and unit square, there is a positive real number that gives the number of unit squares and parts of unit squares that exactly tessellate. We've had that term before, tessellate. The region enclosed by this simple closed curve. So there's no gaps or voids. We're filling in the shape with these squares or parts of squares. An example of what this would look like is, say, let's take this shape. What would I say in terms of units squared? How many squares is this? What would this be? What would the area of this be? Go ahead. 16? 15, yeah, it's 15 squares. I can get that by counting each one. How else could I figure out the area of that? Shatis?
Length by width?
Yes, it's 5 wide and 3 high, right? Or length. The length is 5, the width is 3. So we could take 5 times 3, and we also get 15 units squared. All right. Questions? Area of a rectangle is the product of its length and width. L times W. Postulate 3.3. Any two triangles whose corresponding angles and sides are congruent have the same area. The triangles have the same dimensions, they're going to have the same area. Area of a right triangle. The area of a right triangle is half the product of its legs and the length of its legs. Area of a right triangle. So, so if I have this right triangle and the legs, remember the legs are the two sides that make the right angle. The one across from the right angle is the hypotenuse. So the legs are the two shorter sides. This area would be 1/2 of AB. Why can I use that? 1/2 of AB. Anybody? Okay, go ahead. What were you going to say?
Because two right triangles make a square.
They don't make a square, they make a rectangle. Right. So if I take a rectangle whose dimensions are A by B, the area of that rectangle is A times B. Then I draw the diagonal through the rectangle, and now I have a right triangle. The area of the triangle is 1/2 of the area of the rectangle, 1/2 of AB. So that's why we use 1/2 AB for the area of a triangle. Altitude. The altitude is a line segment from a vertex of a triangle that is perpendicular to the opposite side of the triangle. The length of the altitude is also referred to as the altitude or height. So when we're talking about the number assigned to the altitude, we call that number height, or you can also call it altitude as well. The side through which the altitude is drawn is called the base of the triangle. Here's an illustration. There's the base. This is the side the altitude is drawn to, and we call this height or altitude. The dotted line is the height or the altitude of the triangle. Theorem 3.3. The area of a triangle is half the product of the length of one side and the height to that side. So the area of the triangle was 1/2 base times height. So examples of bases and heights in triangles. In a right triangle, your base and heights are going to be the legs. You can take this isosceles triangle or scalene triangle, either one, and we drop the altitude from the vertex to the perpendicular to the base. That's height. This is base. And then if you have an obtuse triangle, it's a little bit different. For an obtuse triangle, my altitude, my base is if we drop the altitude from this vertex, my altitude is actually outside of the triangle. It's perpendicular to the line and an extension of the base. So that's the height. Outside of the triangle. We're still calculating this area in here the height we use is outside of the triangle in an obtuse triangle. Something else that to be aware of it is the base does not have to be the bottom side. I might have a triangle like that looks like this, right? Then I'd call that the base, and this the height. So it doesn't have to be sitting on the base. Calculate the area of triangle XYZ. We're going to write our area formula. Area equals 1/2 base times height. What am I going to plug in for my base and height? Let's see. Yes, Nina.
The base would be the 6.9 centimeters, and then the height would be 5.8 centimeters.
Yes, good. She used, so she didn't use 7.2 because there's no altitude or height drawn to that side. So she knew to use, I have to use 6.9 because that's what the altitude is drawn to. So it's area equals 1/2 6.9 times 5.3, and that's going to give me 18.3 centimeters, and then we're going to use square units. 18.3 centimeters squared. Any area is going to have squared units. Converting units of area using dimensional analysis. We have to convert 10 yards squared to feet squared. I talked about this when I introduced the construction project. How many feet squared are in a yard squared?
9.
How'd you get that, Steve?
Because if I were to draw a square and say that this was all 1 yard square, then since it would be the same on every side, and 3 feet equals 1 yard, it would be like, and then 3 times 3 equals 9.
Right. Okay, we have 1 yard. If I draw 1 yard squared, so this is 1 yard by 1 yard. That's the same thing as if I split this into feet, it's 3 feet by 3 feet, which is, as Shati said, 9 feet squared. So I would take 10 yards squared, and I do dimensional analysis. 10 yards squared times 9 feet squared over 1 yard squared, and that's going to give me 90 feet squared. There's 90 feet squared and 10 yards squared. Questions? All right. An Olympic-sized swimming pool of uniform depth measures 50 meters by 21 meters. The bottom of the pool is to be treated with a sealer. 1 gallon of sealer covers 300 feet squared of the surface. How many gallons of sealer will be required for the job? And they give us the conversion of 1 inch is equal to 2.54 centimeters. That's our link to go from metric to standard measure. So where do you think we would start on this problem? What would we start by doing? Let's see somebody else. Okay, go ahead, Jordan. Jordan, go ahead.
You want to start by getting the area at the bottom of the pool.
Right, we would do the area of the pool, so we take length times width. So we would do 50 meters times 21 meters. We'll just put that over 1, right? And then we have to since we're going to convert from inches to centimeters, we need to convert this meter squared to centimeters. So how would I do that? What would be my next line? Okay, Shatice.
100 centimeters equals a meter.
Right. So to calculate a meter squared, what would I do?
Meter squared.
What would I do to the centimeters?
It would be 10,000.
Okay, 100 times 100, right? Yes. So 100 centimeters times 100 centimeters over 1 meter squared. Then we're going to multiply that times, now we're in centimeters, so we can convert to inches. So we're going to have, the next multiplication would be 1 inch times 1 inch, which is an inch squared, over 2.54 centimeters times 2.54 centimeters so now we need to convert to feet, right? So 1 foot times 1 foot, what am I going to put that over? Let's see, Ellie, what would I put that over? We're converting from inches to feet. Yeah, 12 by 12. 12 inches times 12 inches. All right, and then you multiply all that out. Go ahead and do that multiplication. Make sure you can do this, the multiplication of this correctly. We're going to round up. Let's round up to the nearest foot on this. See what you get. Anybody have it? What'd you get, Jordan?
38 gallons of sealer. Oh, do you mean, okay, 11,303 feet.
Yes, 11,303 feet squared. So if you have to do a problem like this, just multiply everything on the top. So take 50 times 21 times 100 times 100 times 1, and then divided by, then you divide by 2.5. Then you hit the division button again and divide by 2.5 again. Division again, 12. So, for each time you divide, you just keep dividing, rather than try to group things. I think it's easier just to do it as a string. All right, so we've got the 11,000 some odd feet there. Now we have to figure out how many gallons I need. So what are we going to do with 11,303 feet squared? What do I do next? Okay.
Divide by 300 feet squared.
Yeah, we can take times 1 gallon over 300 feet squared. And that's going to tell me I can't buy a part of a gallon of sealer, so how many gallons would I have? Yes?
38.
Yeah, you'd have approximately 38 gallons of sealer needed. Questions? All right, very good. Yes, Shatice.
If you divide 11,303 divided by 300, I got, oh, never mind.
Okay, so 38 gallons.